Today, we will be discussing the origins of life on Earth and how it might have been catalyzed by our active young sun. The building blocks of life, amino acids and carboxylic acids, may have formed thanks to the eruptions from our sun, as a new study suggests. To understand the origins of life, scientists have proposed various theories. One of the earliest theories dates back to the late 1800s, where scientists speculated that life might have begun in a warm little pond, a soup of chemicals energized by lightning, heat, and other energy sources, that could mix together in concentrated amounts to form organic molecules. In 1953, Stanley Miller of the University of Chicago conducted a famous experiment to simulate these primordial conditions. He filled a closed chamber with methane, ammonia, water, and molecular hydrogen, gases thought to be prevalent in Earth's early atmosphere, and repeatedly ignited an electrical spark to simulate lightning. A week later, he found that 20 different amino acids had formed. However, the last 70 years have complicated this interpretation. Scientists now believe that the gases present in Earth's early atmosphere were carbon dioxide and molecular nitrogen, which require more energy to break down. These gases can still yield amino acids, but in greatly reduced quantities. Some scientists suggested shockwaves from incoming meteors, while others cited solar ultraviolet radiation as alternative energy sources for the formation of amino acids. In 2016, Vladimir Eruption, a stellar astrophysicist at NASA's Goddard Space Flight Center, published a study suggesting that during Earth's first 100 million years, the Sun was about 30% dimmer, but solar superflares, powerful eruptions we only see once every 100 years or so today, would have erupted once every 3 to 10 days. These superflares launch near light-speed particles that would regularly collide with our atmosphere, kickstarting chemical reactions. To put this idea to the test, Eruption, along with Dr. Kobayashi, a professor of chemistry at Yokohama National University, and their collaborators created a mixture of gases matching early Earth's atmosphere as we understand it today. They shot the gas mixtures with protons, simulating solar particles, or ignited them with spark discharges, simulating lightning, replicating the Miller-Urey experiment for comparison. Their experiments suggest that as long as the methane proportion was over 0.5%, the mixtures shot by protons, solar particles, produced detectable amounts of amino acids and carboxylic acids. But the spark discharges, lightning, required about a 15% methane concentration before any amino acids formed at all. Solar particles appear to be a more efficient energy source than lightning. However, lightning, which comes from thunderclouds formed by rising warm air, would have been rarer under a 30% dimmer sun. To conclude, these experiments suggest that our active young sun could have catalyzed the precursors of life more easily, and perhaps earlier, than previously assumed.